Hello everyone, today we will be talking about proving some theorems that we already know. This is our third and final section in our Intro to Proofs unit. We will do some more proofs in Unit 4, but these are the last ones of this kind that we'll be solving for Unit 3. Alright, we're going to take a look at this proof here for the vertical angles theorem. It says, given the figure to the right, prove that angle 1 is congruent to angle 3, which is what the vertical angles theorem says. The vertical angles theorem says that non-adjacent angles on opposite sides of the intersection are congruent. So 1 and 3 and 2 and 4 would be our options there. Today we're trying to prove that angle 1 and angle 3 are congruent. And you can't use this theorem to prove it, because we have to prove that we can even use that theorem in the first place. So what I am recognizing is that angle 1 and 3, they both have these lines that outline them, and these are straight lines. And if I go up this line, I'm noticing that 1 and 2 are on a line together, and I'm noticing that 2 and 3 are on this other line together. So I'm going to use that information that I can see from my image to prove that this theorem is true. So I'm going to start with angle 1 and angle 2, and I can say that angle 1 plus angle 2 is equal to 180 degrees. And I can say that because angle 1 and angle 2 are on this straight line, and I know that straight lines have 180 degrees, which means that angle 1 and angle 2 are a linear pair. So my reason for why I can say that is because of the definition of a linear pair. If you are trying to figure out what a good reason to use is, for those of you that are at home, you're going to have to go back and look at all of your note packets and look for the theorems and definitions that we've already used and learned. Or if you are in person, we've been creating a dictionary so that you have all of these things in one nice resource. So that's where you're going to want to look. You're going to look for that inside your dictionary. All right, so I have angle 1 plus angle 2 is 180 degrees. All right, for my second line, I have that angle 1 and angle 2 is 180 degrees. Now I need to put that other thing I noticed about 2 and 3 in there. So I can say that angle 2 plus angle 3 is equal to 180 degrees. For that same reason, it's again the definition of a linear pair, because angle 1 and angle 3 are on the same line, which means that they form a linear pair. All right. Okay, so now I have angle 1 plus angle 2 is 180 degrees, and angle 2 plus angle 3 equals 180 degrees. I'm noticing something here. If these two things equal 180 degrees, and these two things equal 180 degrees, then what we have right here is what the transitive property allows us to do. The transitive property says that if something has the same value, then those two things must also be equal. So that means that I can write angle 1 plus angle 2 is equal to angle 2 plus angle 3 because of the transitive property. So that's going to be my next line. I have angle 1 plus angle 2 is equal to angle 2 plus angle 3 by the transitive property. Of equality. Can't forget that part. It's easy too, though. For right now, we're going to leave of equality in the title in our reason, but eventually if you want to just write transitive property, I will take that as well. All right, next we have line 4. This should be the last line, and up here it says we're trying to prove that angle 1 is congruent to angle 3, so that should be our next line, and we're going to see if that works out. So I have angle 1 plus angle 2 is equal to angle 2 plus angle 3. I'm recognizing that angle 2 is on both sides of this equation, so I can subtract angle 2 out, and that leaves me with angle 1 is equal to angle 3. So I have angle 1 is equal to, or congruent is really what we're looking at, angle 3. So I can say by my subtraction property of equality, because we subtracted angle 2 out, that angle 1 is congruent to angle 3. Alright, now that we've finished this one, you might be noticing that there wasn't a line that said given on it, and there actually is a given statement in this one. I just didn't write it down. The given statement is the figure to the right. So we would say, given the figure to the right, because it's given. Because it says given in there twice, we are skipping that piece, but that would be your first line. Alright, so that's the proof of the vertical angles theorem. Now we're going to go ahead and prove the alternate interior angles theorem, which works much in the same way. I'm going to go ahead and switch back to that color I started with. I'm going to try to keep my colors consistent as we go here. Alright, so now we have the alternate interior angles theorem, and it says, given the figure to the right, prove that angle 2 is congruent to angle 7. Alright, so part of my given information is actually in the image, not just in the words that are stated. Right here we have these arrows on our parallel lines that tells me that P and Q are parallel. So my first line is actually that P is parallel to Q because it's given. And that information is, again, not in our instructions, it's in the image. Alright, so now that I know that P is parallel to Q, and I again can't use this theorem because I'm trying to prove that theorem, I can, however, use some of my other theorems. So, for example, I'm trying to get 2 and 7, but what I do know about 2 is that 2 is congruent to angle 4 because angle 2 and angle 4 are corresponding. So I can say that. And I do know that 7 is also congruent to angle 4. So that will be what I am going to go. That's my route. I need to show that 2 is congruent to 4 because then I can show that 4 is congruent to 7. And then I can show that these two are congruent. So we'll take this step by step. Line 2, angle 2 is congruent to angle 4. And I know that by the corresponding angles postulate. Corresponding angles postulate. Alright, so now that I have those two lines, I'm going to go ahead and do that third line that I was mentioning before with angle 4 and angle 7. I know that these two things are congruent because they are vertical angles. So I can say in line 3 that angle 4 is congruent to, oh, that's not the congruent symbol. Let's try that again. Angle 4 is congruent to angle 7 by the vertical angles theorem, which we can use because we've already proven that this theorem works. Now, if I'm asking you to prove the theorem, you can't use it. But anywhere else, you can because we've proven this. Alright, so now I'm recognizing that I have angle 4 and angle 4 in both of those places, and I have angle 2 and angle 7 that I'm trying to get to. So what I'm recognizing here is that I again have two lines where they're saying that they're equal to something, and so therefore these two things must also be equal. And that's again the transitive property. So the transitive property is different from substitution, where substitution you're saying, oh, these two things are equal, so I can replace this with that. The transitive property says this has this value and this has this value, so these two things must also have the same value. So I can say for my last line here that angle 2 is congruent to angle 7, which is what we wanted to prove, because of the transitive property of equality. Transitive property of equality. Alright, so now that we've proven the vertical angles theorem and the alternate interior angles theorem, we're going to go ahead and flip to the next page where we will prove the alternate exterior angles theorem. So I'm going to get my color back here a second. Alright, so the alternate exterior angles theorem says, given the figure to the right, prove that angle 1 is congruent to angle 8. Okay, so just like before, I have to first acknowledge that I have this given information in my image that tells me that my lines are parallel. So I have P is parallel to Q because it is given. And again, it's given in the picture, not in the instructions. Alright, now I'm trying to get from 1 to 8. And I'm recognizing that 8 and 3 are vertical and 1 and 3 are corresponding. So I'm going to use a very similar process, and I'm going to show that my angles are congruent by showing that other angles are congruent to each other as well. So I have angle 1 that I'm going to start with, so I'm going to say angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3, and I know that because of the corresponding angles postulate. The corresponding angles postulate. Just a reminder, postulates are things that we are allowed in math to say that this is true without proving it. So because of that, a postulate is a really good thing to put in a proof because you don't have to have proven it. It's just automatically true. Alright, so we have angle 1 is congruent to angle 3. And I also am noticing that angle 3 is congruent to angle 8. So I'm going to write that as my next step. I have angle 3 is congruent to angle 8. And I know that that is true by the vertical angles theorem, which again we've already proven, so now we can use it. So this is true by the vertical angles theorem. Alright, and if you didn't have this theorem, you could still get there, but it's going to take a little longer. Alright, so now that we have that angle 1 is congruent to angle 3, and angle 3 is congruent to angle 8, we're now set up to use our transitive property to jump to say that angle 1 must also be congruent to angle 8. So I have angle 1 is congruent to angle 8 by the transitive property of equality. Alright, so that's the alternate exterior angles theorem. So now that we've proven this, we can use it. Unless, of course, you're trying to prove this, in which case this should be your proof. Alright, at least for this class. In some future classes, you might be asked to specify a few things a little bit more in detail. Alright, I'm going to switch my color back, and now we're going to scroll down, and we're going to solve the same side interior angles theorem. I'm going to try to turn the light back on. There it goes. Alright, so in the same side interior angles theorem, this one is going to be just slightly different than some of the other ones. So we have, given the figure to the right, prove that angle 2 and angle 3 added together are equal to 180 degrees. So we again are going to start with recognizing that in this image we have these markings on our parallel lines that tell us that they're parallel. So I have P is parallel to Q because it's given. Alright, next we have in here, I'm trying to figure out how to get from 2 to 3 and show that they are, the sum of them is 180 degrees. So before I can say that, I need to see what else I know. I know that this is a straight line and 1 and 2 are both on this line. So I know that these two things add up to 180 degrees. And let's see, do I know anything about angle 1 in relation to angle 3? And the answer is yes, I do, because these are corresponding angles. So I think those two things are going to help me out. I'm going to start by writing down that angle 1 and angle 3 are corresponding angles because I think that's going to be of some help to me. So I have angle 1 is congruent to angle 3 by the corresponding angles postulate. All right. Then I have, for my next line, I'm going to write down that other thing that I pointed out that said that angle 1 and angle 2 are on the same line, so they have to be supplementary, or so we're going to start by writing out that angle 1 plus angle 2 is equal to 180 degrees. And I know that because these two things are, again, a linear pair, so that is the definition of a linear pair. All right, and then now I have angle 1 is congruent to angle 3, and angle 1 plus angle 2 is equal to 180 degrees. So if angle 1 is congruent to angle 3, that means that I can replace angle 1 with angle 3 when I'm solving. So instead of having angle 1, I'm going to say that angle 3 plus angle 2 is equal to 180 degrees. And I know that this is true because of the substitution property of equality. Substitution property of equality. And that is our proof. And these two things are the same. It might be a little bit better for you if you were to rewrite this. So instead of saying angle 1 plus angle 2, you could say angle 2 plus angle 1. And then when you're replacing it, it will be in the same order. So I am going to just go ahead and switch the order of those things so that it lines up, but it doesn't really matter. I will say, though, that technically, if you want this to be a true proof, if you had those numbers switched around like I just did, you would need to write another line and say that you can flip them by the associative property of addition because they're the same thing. So everything you do in one of these proofs, you have to write it out with its reason, even if it's something that you know you can do. You have to say why you know you can do that. All right, this is the last theorem that we're going to prove for today. There were only 4 of them. You had the vertical angles theorem, the alternate interior angles theorem, the alternate exterior angles theorem, and the same side interior angles theorem. Every theorem that we have used or learned has a proof and can be proven. We're not going to go through and prove all of them, but these 4, I do expect that you are able to prove them on your own. All right, this is where we're going to end our 3rd unit. We will do a little bit more practice, and then we will have our unit test following our review. We will pick back up with Unit 4, which will include a few more proofs.